Thanks for your interest on the Skater Mini. All the shots that you've seen in the demo sequence were done using a skater. Some do look a bit like motion control, but they're not. They're all shot with this little tool. Before we look a bit more in detail in how the skater is working and what it can do and what not, I'd like to introduce myself. I'm Sebastian Kramer. I'm a director, and sometimes I also work as a director DP. I've invented the skater and used it for quite a while on my own projects. It's now built, further developed, and distributed through PS-tecbnik in Munich. Let's have a quick look at the idea behind the skater. If you look at the very simple camera move on a dolly, you have two components to deal with. One is dolly and the other is the camera head. In between there is a supporting system to mount the camera head on the dolly. But if you start thinking of a system where a dolly and a camera head aren't two separate components anymore, you can actually create something that is extremely flat and very lightweight. If we take a closer look at the skater, we still do have a very simple camera head in the center, which allows you to adjust tilt angles, and we do have three wheels around it, which is the dolly part. In terms of height, it's about 10 to 20 times flatter than standard components. Let's have a look at the operating elements. In this top shot you can see that each wheel has a big letter for identification. If you open up the tilt brake, it allows you to adjust tilt angles on a range of plus to minus 20 degrees. You can also see how extremely flat the skater is, with a height of only 2 inches or 51 millimeters to the mounting surface of the camera. The integrated dovetail allows you to work with almost any scene sliding plate, or you can lose this dovetail and mount any other camera. By pushing this little orange knob to the side, you can easily change to the plus minus 30 degrees rocker, which is actually a pretty wide range for tilt angles. Each wheel has detailed scales showing units in degrees. White is used for positive values and yellow for negative. And finally there is a position brake to avoid any change of position if the skater is not operated. Well, that's all you have to know about the operating elements. It's actually extremely fast to get the skater ready to shoot. You just put the camera on top of it, you use the integrated dovetail and slide it on. If I do this by myself, it doesn't mean you don't need a first AC. And then you choose the desired tracking direction for all the three wheels, and you fix the tilt angle for your shot, and you open up the brake, and then you're ready to make the track. And it almost needs no force to be pushed. If you change the angle to 0 degrees, you make a straight track in. This is how it looks to the camera again. You can also make angled moves. This is a shot here on 35 degrees, which is nice because it's tracking in, but it also gets some depth. Here are some shots from various productions. This first shot is a straight track in on a 50mm lens, as well as a next shot which was also done on a 50mm lens. It's an angled move about 45 degrees and it was shot at 33 frames per second. Here the skater is actually pushing the ball into the hole. Again, it's a straight track and it was done in almost no prep time. As you can see here, the skater is so lightweight that you can do extreme accelerations and decelerations, which is obvious in this shot here at 150 frames. That would be tricky to do with any other dolly equipment. So it's pretty obvious the skater makes a lot of sense for tabletop and food photography. Here are some work samples showing work on location. So in this shot the skater is simply running on a board which was leveled with wedges, while in this sample the axis was very limited as the scene is happening on a roof. So it helped a lot not to bring up a standard sized dolly. In this shot here, the actor is looking for a hidden bomb in the air conditioning system. It was very limited space for doing this track into his face, and again it was done in almost no time with no additional rigging. This shot here was done in a freight elevator on Super 16, and the actor is waiting until he makes a final run. And as you can see in the making of, the skater is so lightweight that you can actually lift it up together with a camera, which is something I wouldn't recommend with any other dolly. The biggest power of the skater probably lies in its capability of doing all sorts of circular and curved moves. To do this, you just have to align all axes to one center of rotation. We use this basket here. Let me show you how this works. So you change the wheel angle and open up the brake, and there you make a nice curved move around this basket. And again you see nice accelerations and decelerations. As you can see, this was done with almost no prep time. Shots like this, which very often require complex rigging or even motion control. If the center of rotation is in front of your lens, you do some kind of an orbiting shot around an object. But it doesn't have to be there, it can virtually be anywhere. So if it's a bit off to the side, let's say you pick this point here, what you would do is some sort of a curved move. So you would start looking into one direction and then track into a new direction. Let's see how this looks. So here we're shooting this way into the first setup, and then we're tracking into a new setup, which still has some nice feeling of a bit of a track, as you can see here in this 35 shot. And it's a very simple rule. The closer the center of rotation is to the skater, the more you get a feeling of a curve. The further it's out, the more you get a feeling of a track. This is a typical sample of a curved move. As you can see in the final shot, the camera is first looking into the kitchen and then tracking into the final product shot. While in the shot here, the camera is rotating around a point in front of the lens. Here's a shot filmed on a Sony HD camera together with a P&S Mini 35 image converter, and as you can see, the camera is rotating around a center of rotation which is in the book in front of the young lady. This looks like a straight track, but it's not. It's actually a slight curved move, and it's rotating around the far corner of the CD player. And again, this is also a curved move. It was shot in reverse, as you can see here in the making of shot. The performance of the skater highly depends on a precise lineup of each wheel. And we strongly suggest not to simply guess the values, because that's kind of tricky. There are very easy ways of aligning 3 wheels. There's one thing you should know. There's a little reference mark in front of the skater with a little triangle. And all measurements refer to this one point. So if you want to do a rotation around this basket, the only thing you need to know is the distance from the basket to the reference mark, and that would be 50 centimeters. And then there is this little table, which is very easy to use. It has 2 sides, one in yellow for centimeters and the other one in orange for inch. It has various lines, and the first number is the distance from the reference mark to your center of rotation. And then you get 3 angles for wheel A, B, and C. So let's say it's 50 centimeters. We have to adjust minus 71.2. Negative is yellow. Don't mix up the negative and positive values. 70.5. Wheel C has 80.5. Then you simply just open up the brake and you see this nice curved move, which you have seen in the previous chapter. If the center of rotation is not straight in front of your lens, you do have a kind of a side offset. So there are 2 values to deal with. One is the distance in camera, which is positive if it's in front of the reference mark and negative if it's behind it. And then there is a side offset, which is again positive to the right and negative to the left. So in this little example we had in the previous chapter, we wanted to make a rotation around this marked point here. So to get the 2 values, you just measure the distance in camera direction, which is 2 centimeters, and then you have a side offset of 25 centimeters. And then there's a little program existing as a Palm and an Excel version. It's a free download on the PS-tecbnik website. You can get it, check it out, how it works. It's very simple. If you look at the screen here, we have 2 values for distance in camera direction and offset to side, and we get the 3 values for A, B, and C. You can toggle to inch. You just type in the 2 as a camera direction and then minus 25 for the side offset. And here you get the 3 values, A, B, and C. So the only thing that you then have to do is to align those 3 wheels, and then you can see this is the movement that we had in the previous shot, this curved move coming from one setup to the other. And you can also see it's making a nice rotation around this point that is marked here. And there you go, this was the movement we had in the previous chapter. There's another very easy way of adjusting rotation centers, and that is this little laser pointer. You just put the laser pointer on these 2 registration pins and you aim with the laser point at the desired center of rotation. You do this with all the 3 wheels, as you can see here. And with the 3rd wheel. And you open up the brake, and you see it makes a very nice smooth rotation around this orange. There are some occasions where the camera is in the way if you want to point with the wheel C. In this case, you simply go to another mode in the rotation calculator, which is the angle mode that you can find here. It allows you to enter 2 values for scale A and B, and it is calculating scale C. It also tells you where your center of rotation would be. So there are 3 ways of adjusting rotation centers. They're all very fast. Using the laser pointer makes a lot of sense if you can't get into the set because it's very packed and crowded. This shot here shows the German answer to sushi. And it looks like a digital effect, but it's not. It was all done in camera, and the flying sausage was hanging on little tungsten wires, and it was actually used as the center of rotation with the laser pointer, and all wheels were aligned to this one point. Here the center of rotation is calculated with the rotation calculator and then adjusted, and you can see how the camera is moving in the final shot. Here's another sample, and the center of rotation is in front of the yellow half. Well, in this shot, a little tape mark was used to have a specific point for the laser pointer to point at. And in this case, the rotation calculator in angled mode was used to get a proper alignment for wheel C. You can also see how extremely small the board is on which the skater is running on. You might say, that's a nice tool, but my next project is not happening entirely on the table. As the skater has no internal lift, we'd like to talk about adjusting camera heights. Probably the easiest way of doing this is to change to the big rocker if you just need a very small amount, like we did here with the Sony HD camera together with the PS Mini 35 image converter. It's also helpful if you're using BL cameras where you have a big magazine in the back. So to get a bit more clearance in the back, it's good to change to the big rocker. If you want to gain a bit more height, basically the only thing you need is a board. And here we took 2 Pedaninis to lift this board up about 10 to 12 centimeters. You could use Apple boxes. That's all very fast and quick. So if you just want to have a small track, there you go. Another very fast solution to adjust camera heights is to use those leveling supports. They do have a screw for fast adjustment on leveling, and they have a 28mm pin that works together with standard lighting equipment. You can either build them yourself very quickly, or you can get them through PS-tecbnik. Here they sit in a turtle base, and if you want to extend those with standard onkoponkos, how they called, then you just put them in here and build whatever height you need for your shot. Here we have a low boy with another leveling support, and basically again the only thing you need is to put another board on top. Then you take the skater with the camera, and as the skater is very lightweight, you don't feel a lot of shakiness here because it doesn't need much energy to push the skater. So to make basic camera tracks, there you go. This entire sequence was shot on the skater, but the idea is not so much to replace a conventional dolly, but use it whenever it's faster and more efficient. So in this first shot, basically a board is lying on the floor, and it only took 2 wedges to level it. You can also see the board has little borders to avoid the wheels from going off the board. Here the center of rotation is about 1 meter behind the camera, and the laser pointer was used to get a proper lineup. This causes the skater to make a kind of a curved move, which is adding a bit of a panning feeling to the track. In the second shot, we took 2 low boys with 2 leveling supports and placed the board right on top. And you can see how fast the leveling actually is. And again, the skater is doing a little curve, and the center of rotation is behind the camera, adding a bit of the panning feeling to it. Here the board is sitting on 2 Apple boxes, and the center of rotation is in front of the camera, behind the actor. For the final shot, we took 3 turtle bases with pin extensions and 3 leveling supports, and the center of rotation was in the pistol about 60 centimeters in front of the reference mark, and the shot was done on a 24mm lens. Instead of changing the lens height, you can also change the height of your object. Like we did here with this whiskey glass. We raised it up about 10 centimeters and the shot was on a 100mm macro on 50 frames per second. Here's another sample. The height of the flower was also adjusted to match the lens height. So there are various ways in either adjusting the lens height itself or by changing the object height. Each scale has little marks with an L and an O. L stands for locked, and if you adjust all wheels to the L position, then all the wheels are facing into the center of the skater. So that gives you an adjustable rocker plate for fixed camera angles. And if you change to the O position, O stands for circle, you can execute basic panning shots. As you can see here, with a bit of practice, you can make nice stops. This is a pan on the skater. You can see how extremely small the board can actually be. You don't even need a board if you just want to use the skater as an adjustable rocker plate like we did in this fixed shot here. This setup is a bit odd, but it works. It's showing that you can actually use the skater as a very basic turntable if you want to rotate an object. Here you can see that the rotation is either around the lady's face, or you put it here onto the lion's face, and then we make a rotation around the lion's nose. This lady is actually the Scenic Award that we received in 2004 when we introduced the skater to the public. As you can see here, the skater is rotating around the scale and the scale stays in the center. That could be helpful for tabletop photography if you have an object that doesn't rotate around the center. So the center of rotation is right here. I have no clue whether you need it or not. Another very interesting option is this Skater Mini Steady Back. You just place the bracket into the frame of the skater, and then you put the camera on top of it, and you basically just adjust the angle you want to shoot at, open up the brake, and there you go. The Steady Back also allows you to work with Dutched camera angles, as you can see here in the next shot. Or in this shot on the latte macchiato glass, and you can see that the center of rotation is not in the glass but it's in front of it, and that causes this glass to wipe through that frame in the shot. This is an interesting setup. It starts on a steady back and then is continued handheld. So this shot was supposed to start with a bit of a suspense feeling, and then it was continued as a handheld action sequence. You can also see how extremely tight the working area was. It was about 2 square meters. Also, the skater is running directly on the concrete floor, which is actually a pretty bad surface, and it was not visible in the final shot at all. Working with periscopes or borescopes can add interesting perspective to the shots you do with the skater. Like in this setup, we have a 90 degrees periscope looking down on this leather man, and as you can see here, we do a rotating shot around this leather man. In this case, the camera is lit back, so we use a separate sliding plate and not the integrated dovetail to get a nice balanced setup. This shot on the burger was done with a straight boroscope, and you can see it makes a slight curve from the actual burger into the toppings. And this was done with a center of rotation about 50 centimeters left of the camera. You can nicely see the starting and focus marks. In this shot, the skater again is running on a separate board, and it was also done with a straight boroscope. You can see the starting and end marks, and here's the shot on 35. Let's have a look on this shot here. It was using an angled periscope on 90 degrees, and the center of rotation is at the yellow mark. And again, the laser pointer together with the rotation calculator in angled mode was used for a lineup. This shot again was done on a 90 degrees periscope looking down on a 50mm lens. It could have been done with the rotating table, but in this case it was very important that the light remains constant. The accuracy on a skater move highly depends on the proper lineup of each wheel. So don't guess values for rotations. Use a proper lineup. Another thing is how the skater is pushed and pulled. So if you see here, I'm moving the skater and I'm bringing it back, and you see it precisely hits the same position. But if I pull the skater while I'm moving, I do get an offset of a few millimeters. That wouldn't be visible in the image, but after a couple of takes, you might want to get back to the original position. If you mark 2 wheels, you can always come back to the original position. That's a fast way of doing this, and it makes a lot of sense. Also helps the focus puller to get a proper focus, especially in macro photography. So working with those marks does help a lot, and we suggest to work with those marks. I work with those marks. In this shot of the rose, you can nicely see the starting and various focus marks. Here's a shot on 35. You can also see that the power and video cables are supported to avoid any tension from these cables during the shot. Also, always make sure that the wheels of the skater are clean and dry. If you feel they should be cleaned, just use a bit of a soft fabric with a tiny bit of dishwashing lotion, and then simply put it on the skater wheel and track while you're holding it against it. Just make sure that the wheels and the surface is dry before you actually start shooting. Here you can see the cleaning of the wheels during production, and you see how easy this is. You can also nicely see the starting and various focus marks, and again the support for the cables. There's one more thing, not so much about the accuracy of the move, but about the smooth feeling of the move. And we suggest to use follow focus motors rather than to use a follow focus with a flexible shaft. With a flexible shaft, you can get a bit of a pushing or pulling from the focus puller, and that might be visible in the shot. Many thanks watching this DVD to the very end. I hope you have a chance in the future to check out the skater and see whether it makes sense for your work. We do consider it a bit like an open system. So whenever there's something that you feel could be improved, if there's things you like or you dislike, please let us know. Many thanks. Goodbye.